start our session. Now we are going to discuss magnetization method used in magnetic particle testing. This is a very important foundation because the way a material is magnetized determines the accuracy of defect detection. Let's start the session. Magnetization methods. Magnetic field categories. There are two major categories of magnetic field we use in the testing. First one is circular magnetic field and the longitudinal magnetic field. First, the circular magnetic fields. These fields flow in the circles inside the material. If this is the material, usually created by passing a current through the part, then the magnetic fields are created circularly. So this is the circular magnetic fields, or through a conductor inside it. They are best for finding longitudinal cracks. Circular magnetic fields used to find longitudinal cracks that run along the length of the part. This is the circular magnetic field. The next one is longitudinal magnetic fields. The fields run in straight lines. This is a material and the magnetic field passes through this straight lines. This is a longitudinal magnetic fields. So the field run in straight lines along the length of the test object produced by coils or yokes. They are most effective for detecting the transverse crack. This is the transverse crack. This is the longitudinal cracks. This is the transverse crack that cut across the part. This is the longitudinal magnetic field. So we discussed about circular and longitudinal magnetic fields. Next, the key factors affecting test parameters. Now the effectiveness of magnetization depends on several important factors. The first one is alloy, shape and magnetic condition of the test object. So the different materials and shapes respond differently to magnetization. For example, high carbon steel. So high carbon steel retains more magnetism than low carbon steel. So magnetization differs from the alloy and shape and magnetic condition of the test object. The next one is type of magnetizing current used. Yes, we have using AC, DC or a half wave DC or full wave DC. All have unique effects on how deeply the field penetrates the part. The next one is direction of magnetic field applied. So defects can only be detected when they cut across the magnetic flux lines. That's why direction is critical. The next one is sequence of operations in the testing processes. Proper order of magnetization, application of particles and demagnetization. These all ensures accurate results. The next topic is value of flux density achieved. The strength of the magnetic field must be high enough to reveal the defects, but not so high that it causes excessive background indication. So these are the key factors affecting the test parameters. We mainly use circular and longitudinal magnetic fields and the effectiveness depends on the material's property, current type, field direction, testing sequence and flux density. So we can see the next video. Thank you.